Hello students, welcome to the class. So in the previous class, we had discussed around 14 questions. Moving to the next question, 15th one. Hydrogen peroxide molecules are monoatomic and forms X2 minus 2 ions, diatomic and form X minus ions, diatomic and form X2 minus ions, monoatomic and form X minus ions. See, when this hydrogen peroxide molecule dissociates, what it forms? Yes, so we need to understand that, then we can say what ions are formed and what type of molecule it is. So we know that hydrogen peroxide is H2O2 and it is what? It is a diatomic molecule made up of two atoms. It is a diatomic molecule. And when it dissociates, it will form H2O2 will dissociate to form H plus ion plus HO2 minus ion. So this ion is nothing but X minus ion. Yes. So this ion we call it as hydroperoxide ion. What it is called as? It is called as hydroperoxide ion. Yes. So when H2O2 is what type of molecule? It is a diatomic molecule and it dissociates to form what? It dissociates to form HO2 minus ion. So if this is considered as X, it will form X minus ion and that ion is called what? It is called hydroperoxide ion. So which is the correct option? It is diatomic and forms X minus. Yes, option B is the right option. Okay. Then which of the following is the true structure for H2O2? See, H2O2, we know that what type of molecule is H2O2? It is non-linear molecule and it is non-planar molecule. So in our previous video itself, we have seen the structure. It is open book structure, like right in gas phase also we have seen, and in solid phase also we have seen. So which is the correct structure? Is this the correct structure? Yes. So it is not the correct structure because here bond angle comes out to 180 degrees or here the bond angle comes out to 180 degrees. Is this the correct structure with a 90-degree bond angle? No, that is also not correct. H2O2, is it having this linkage? No, it is not having this linkage. Double bond linkage is not there. Then it should be option D, because when you look at this structure, then the OOH bond angle, this bond angle, or you can say this bond angle, it comes out to 97 degrees. Approximately we have seen in gas phase or in solid phase, its bond angle is what? 97, 98 degree bond angle is there. OOH I'm speaking, not the dihedral angle. Yes, so it is 97 or 98. So this becomes the correct option. So that is the correct structure for hydrogen peroxide. Yes. Is that right? The OOH bond angle in H2O2 is. So the OOH bond angle in H2O2 is what? It is 97 degrees. 97 degrees. The reaction of H2O2 with H2S is an example of what type of reaction? Options given are addition reaction, oxidation reaction, reduction reaction, acidic reaction. Yes. So here, if you look at this, H2O2, reaction of H2O2 with the H2S. So what happens when H2O2 reacts with H2S? It will form H2O plus two molecules of H2O plus S. So what is happening here? Hydrogen sulfide is reduced to sulfur, correct? It is reduced to sulfur. Therefore, yes, hydrogen sulfide not reduced to sulfur. It is what? It is oxidized. So hydrogen sulfide is oxidized to sulfur. Yes, that means it is oxidized to sulfur means what? This is what? So H2O2 oxidizes H2S to S. Yes, therefore, what type of reaction it is? It is what type of reaction? It is oxidation reaction. It is what? Oxidation reaction. Okay. Next, some statements about heavy water are given below. Heavy water is used as moderator in nuclear reactors. Heavy water is more associated than ordinary water. Heavy water is more effective solvent than ordinary water. Which of the above statements are correct? And they have given these options. See, when we speak about heavy water, what is heavy water? Deuterium oxide is heavy water. Yes, D2O. Correct. So deuterium oxide, heavy water, it is used for what all purposes? It is used for slowing down. See, we say it is used as moderator and coolant. It is used as moderator and coolant in nuclear reactors. Now, what is the work of heavy water as moderator and coolant? What does it do? What it does is there will be in the nuclear reactor, nuclear fission and nuclear fusions will be taking place. When nuclear fission occurs, there will be highly moving, high speed neutrons coming out. So deuterium oxide, that is what? Heavy water, it is used for slowing down. It is used for slowing down the speed of neutrons. It is used for slowing down the speed of neutrons. Yes, in the nuclear reactors. Hence, we say it is used as a moderator. Now, if you look at boiling point of heavy water of deuterium oxide is how much? It is 374.42 Kelvin. So I can say it is more than the boiling point of our normal water, H2O. Because our boiling point of our water is how much? 373 Kelvin. Yes, 100 degrees Celsius means what? 373 Kelvin. Hence, we can say heavy water is more associated. Associated means what? It is clumped together too much. Therefore, we are needing more energy to break those bonds. So it is more associated. Coming to dielectric constant. The dielectric constant, we have discussed this when we were discussing the concept, right? Of ordinary water, of our ordinary water, it is greater than dielectric constant of heavy water, D2O. Yes. Therefore, we can say ordinary water is a better solvent. Because it will dissolve more number of compounds than heavy water, since its dielectric constant is more. So which are the two statements correct? First statement is correct, second statement is correct, but the third statement is wrong. Therefore, I can say first and second statements are correct. First and second statements are correct. So it is option A. It is option A. Okay. Next question. Which of the following will not displace hydrogen? Now, this question is based on what? It is based on the electrochemical series. It is based on the electrochemical series, or you can call it as a reactivity series. So, a more reactive element will displace a less reactive element from its solution. Therefore, if you look at the electrochemical series, you can see that mercury is there. Out of these given, this is most reactive, then comes tin, then comes lead, then at the bottom after hydrogen, copper, there is mercury. So mercury is least reactive compared to all these. Yes, barium comes first, then tin comes, then lead comes, below that hydrogen comes, below that mercury comes. So below hydrogen is mercury. Therefore, mercury being less reactive, yes, being less reactive than hydrogen, it cannot displace hydrogen from its solution. Otherwise, you take barium and treat it with HCl, you will get barium chloride plus H2 gas displaced. You take lead, treat it with HCl, you will get lead chloride, PbCl2 plus hydrogen gas displaced. You get tin plus treat it with HCl, you get stannous chloride, Cl2 plus hydrogen gas displaced. But if you take mercury and treat it with HCl, there will be no reaction. Why there won't be any reaction? Because when a metal is treated with an acid, it gets displaced. It gets displaced from its solution. Hydrogen gets displaced from its solution only if the more reactive element is present, more reactive element than hydrogen. So this will not displace hydrogen from the solution, because it is present below hydrogen in the reactivity series or electrochemical series. Correct? Okay. Next question. Which of the following statements is correct? Option A, hydrogen has same ionization potential. IP stands for ionization potential as alkali metals. Hydrogen has the same electronegativity as halogens. It has oxidation number -1 and +1. It will not be liberated at anode. See, does hydrogen has same ionization potential as alkali metals? No, hydrogen is having very large ionization potential as halogens. Does hydrogen has same electronegativity as halogens? Halogens are, I can write it here, taking the first option into consideration. Yes, hydrogen, it is having large ionization potential. Yes, like halogens it is having, like it is around 1312, we have seen kilojoules per mole. So ionization potential is very high, whereas for alkali metals ionization potential is very low. Yes, second option says what? Hydrogen is more electronegative than has same electronegativity value as halogens. Hydrogen electronegativity value is what? The electronegativity value of hydrogen atom. Yes, in combined state, the electronegativity value of hydrogen atom according to Pauling scale is 2.1. Whereas if you see fluorine, it is highest 4, chlorine 3.5, 3.3 something, then bromine in this range only. So it is not having the same electronegativity value. Yes, then if you see other options, the third option, it's metal hydrides. See, if it is combining with metal plus hydrogen, it will form metal hydride. And in metal hydrides, ionic metal hydrides, metal will have positive charge and hydrogen will have negative charge. So hydrides are what? They are ionic, or you can say anion of hydrogen. Correct? So hydrogen will have negative charge. But when it is combining with a non-metal, say NH3, yes, in that case H2O, if you see, hydrogen is going to have positive charge. CH4, hydrogen is going to have positive charge. So in metal hydrides, OS oxidation state of hydrogen is -1. Otherwise, it is what? It is always +1. It is always +1. Only in metal hydrides, it is -1. Otherwise, it is +1. So that statement is correct. That statement is correct. And then it says what? It will not be liberated at anode. No, hydrogen gas is always liberated at anode. When we take ionic hydrides, usually hydrogen gas being negatively charged in nature, hydrogen ions form hydrogen gas, which will be always liberated at anode. Yes, always liberated at anode. Next question, which of the following pairs of substances on reaction will not evolve hydrogen gas? Will not evolve hydrogen gas. So options given are iron and H2SO4, iron and steam, copper and HCl, sodium and ethanol. See, when you take these examples, the first example is iron and H2SO4, Fe plus H2SO4. We know that iron being a less reactive metal, iron will react with steam. Yes, neither boiling water, it will react with steam to liberate hydrogen gas and form FeSO4 plus hydrogen gas. So it will not react with H2SO4. It will not liberate hydrogen gas here. Yes, you have to take either boiling or you have to take concentrated. So it will not evolve hydrogen gas. Otherwise, iron with steam, yes, it will evolve. Copper and HCl, Cu plus HCl gives what? It will give CuCl2 plus H2. CuCl2 plus H2. Here I will balance it by writing 2. Sodium and ethanol. Sodium and ethanol. So Na plus C2H5OH. It will form C2H5ONA salt and liberate hydrogen gas. Rest all will liberate hydrogen gas, but only iron and H2SO4 in aqueous solution does not liberate hydrogen gas. Okay. Next question. Following are some properties of hydrogen. Which of the following properties resemble with alkali metals and with halogens? Hydrogen lose one electron to form unipositive ion. Hydrogen gain one electron to form uninegative ions. Hydrogen forms oxides, halides, and sulfides. Hydrogen has very high ionization enthalpy. Hydrogen forms a diatomic molecule, combines with elements to form hydrides and covalent compounds. Alkali metals resemble first, third, and fourth property. Alkali metals resemble first, third, and fourth property. Alkali metals resemble first, and halogens resemble second and fifth property. Second and fifth property. Next option, alkali metals resemble first and third property. Halogens resemble second, third, and fifth property. Alkali metals resemble first and third property. Halogens resemble second, fourth, and fifth property. Alkali metals resemble first only, and halogens resemble fourth and fifth property. See, if you look at the first property, what is the first property? Hydrogen lose one electron to form unipositive ion. Unipositive ion. So it will lose one electron to form H plus ion. Similarly, alkali metals also lose one electron, like lithium also loses one electron and form lithium plus ion. Correct? It will lose one electron. Correct? So this is the property of what? Alkali metals. Yes, it is the property of alkali metals. Second, hydrogen gains one electron and form, yes, hydrogen gains one electron and form H minus. This is the property of what? Fluorine also, like halogens, all the halogens will gain one electron and form F minus ion. Why? Because all the halogens are one electron less to obtain noble gas configuration in their valence shell. Therefore, they will gain one electron and form uni-negative anion. So this resembles the property of halogens. Then third property, hydrogen forms oxides, halides, and sulfides. Okay, yes, hydrogen forms oxides, halides, and sulfides. So it forms H2O, it forms H2S, it forms HCl. This is the property of what? This is the property of halogens. It is the property of halogens, yes or no? Hydrogen forms oxides, sulfides, and halides. It is the property of alkali metals. Alkali metals. See, similarly, sodium forms Na2O. Correct? Na2O. Then sodium forms sulfide, Na2S. Sodium combines with Cl and form NaCl. Correct? Then hydrogen form has a very high ionization enthalpy. Yes, hydrogen has very high enthalpy like halogens, because halogens, they tend to gain electrons very easily because of their smaller atomic size. Losing of electrons is very difficult. Therefore, they have very high ionization energy. So this is the property of halogens. Hydrogen forms a diatomic molecule, combines with elements to form hydrides and covalent compounds. Yes, this is the property of what? This is the property of halogens. It forms hydrides. It forms diatomic molecules and forms covalent compounds. Yes or no? Therefore, so first property and third property are what? First and third properties are alkali metals, are of alkali metals. Whereas second property, fourth property, and fifth property are of halogens. Resemblance with hydrogen, the of alkali metals and halogens. So which is the correct option? First and third. So no, this is third is here. First and third, alkali metals. Second, fourth, and fifth, it is halogens. So which is the correct option? The correct option is option C. Is that clear? The correct option is option C. Next question. Match the following. Match the following. Okay. So here they have given chemical properties, and you are supposed to match it with the chemical equations. You are supposed to match it with the chemical equations. Okay. So let us match it here itself. Right? Okay. First one. The basic nature. Which one explains the basic nature of water? Yes, look at the reaction. H2O plus Na gives NaOH plus H2. Then H2O, H3O plus OH minus. F2 plus H2O gives H plus F minus plus O2. H2O plus H2S gives H3O plus S minus. See, before going to understanding, let us try to see what are these equations. This is a water and it is reacting with a metal. And there is displacement of hydrogen gas. Na is becoming NaOH, or H2O is reducing to H2. So what is this option? It is reduction property, correct? Okay, H2O plus H2O gives H3O plus. What is this? water molecule will first lose to form H plus and OH minus. H plus being unstable will combine with another water molecule to form H3O plus. What is this reaction called? Autopyrolysis reaction it is called. Then C1 F2 plus H2O gives H plus, so H plus is coming out, plus F minus plus O2, oxygen is evolved. So is it oxidation reaction? Yes. Okay. Then last one, H2O plus H2S gives, see H2S is acid. And therefore here H2 acts as what? H2 acts as base. Yes, therefore this reaction explains the basic property of water. Yes, so let us match it. So basic nature is for fourth property. Yes, so here I can show it like this. Basic nature is for fourth property. Autopyrolysis is what? Autopyrolysis is second property. Then oxidizing nature is third one. And then reducing nature is first one. Reducing nature is first one, correct? So A is what? A is 4. So here we have 2. B is what? B is 2. This is correct. C is what? C is 3. So this is the correct option. And D is what? D is 1. Yes. So this is the correct option. Is that understood? So this is chemical property of water. And here they have given what? They have given the chemical equations. You have to match it according to the chemical equations. Is that clear? Okay. Moving to the next one. The unusual properties of water in condensed phase, that is liquid and solid states, are due to option A, presence of hydrogen and covalent bonding between the water molecules, presence of covalent bonding between the water molecules, presence of extensive hydrogen bonding between the water molecules, and presence of ionic bonding. See, water molecules we know. We already know water molecules. What is the bonding present in water molecules? Oxygen having 6 valence electrons. 2 electrons are involved in sharing with the 2 electrons of 2 hydrogens to form what? To form to form covalent bond with hydrogen atom. So covalent bond with hydrogen atom. So this is one covalent bond and this is another covalent bond. Correct? So this is another covalent bond. Then each oxygen atom, it is having 2 lone pairs of electrons. Oxygen atom, it is having 2 lone pairs of electrons. Unusual property of water molecules in the condensed phase, that is in liquid and solid states. It is due to why? See, from converting to liquid, from water converting from liquid to gas, there is unusual extreme high boiling point of water when you compare it with other elements of the group. The reason is because of the dipole moment present in water. Since oxygen is more electronegative, the dipole moment is towards water, you can say, or since oxygen is more electronegative, oxygen atom gains a slight negative charge, and hydrogen atom gains a slight positive charge, due to which I can represent it like this, correct? We have seen the structure delta plus, that is slight positive and slight negative charges. Because of this, what happens? Oxygen of one molecule shows weak attraction with hydrogen of another water molecule, because this is delta plus. And here, since 2 slight negative charges, oxygen shows weak attraction with hydrogen of another water molecule, because hydrogen has positive charge. Hydrogen of this water molecule shows weak attraction with oxygen of another water molecule, because hydrogen is slightly positive charged and oxygen is slightly negatively charged. Similarly, this hydrogen shows weak attraction with oxygen of another water molecule, as it is negatively charged. So because of this intensive hydrogen bonding, so water molecule can form how many hydrogen bonds? See, a single water molecule can form 4 intermolecular hydrogen bonds. Intermolecular hydrogen bonds. Correct? So it can form 4 intermolecular hydrogen bonds, 2 hydrogen bonds with oxygen and 1 each with each hydrogen atoms. So there are totally 4 intermolecular hydrogen bonds. So because of this intermolecular hydrogen bonding, there occurs what? There occurs association of molecules. There occurs association of molecules. Molecules will come together. Therefore, to break that, we need to put more amount of energy. We need to put more amount of energy, enormous amount of energy. Therefore, I can say the unusual properties of water in the condensed phase from liquid to gas, if you want to do it, it is due to presence of extensive hydrogen bonding between the water molecules, which leads to association, that to extensive intermolecular hydrogen bonding, which leads to association of the molecules, which in turn gives it more energy to break all the bonds, and therefore what happens? And therefore the properties become unusual. Next question. Hydrogen bond energy is equal to 3 to 7 calories, 30 to 70 calories. Then we have 3 to 10 calories, 30 to 70 kilocalories. See, when we speak about hydrogen bond is what? Just now I told you. Yes, since we are talking about water, I will consider water only. Yes, I'll show it here better. So I'll take only one molecule of hydrogen bond formation. Okay, this is what type of bond? This is covalent bond. Yes, so here the hydrogen of this molecule will attract slightly the oxygen of another water molecule. Why I'm saying it slight attraction is because here it is having partial positive charge, and here oxygen is having partial negative charge due to difference in the electronegativities, since oxygen becomes more electronegative. So this attraction, what you are seeing, this attraction is very weak attraction. Yes, so hydrogen bond is weak force of attraction existing between the molecules. It is weak force of attraction. Therefore, the energy, its energy is equal to how much? It is around 3 to 10 calories only. It is 3 to 10 calories. That's the reason hydrogen bond is shown by dotted lines. It is shown by dotted lines. Yes. Next question. D2O is preferred to H2O as a moderator in nuclear reactor. Just now we had seen deuterium oxide, that is heavy water. It is used as moderator and coolant in nuclear reactors. Why it is used? Because it slows down the fast moving neutrons. Why it slows down the fast moving neutrons? See, instead of deuterium oxide, if you would have used H2O, what H2O would have done is water molecules would absorb neutrons. More as compared to deuterium oxide. And what this would happen, since water molecules would absorb neutrons, there would be decrease in number of neutrons. So when there occurs decrease in number of neutrons, the process becomes slow. So the number of neutrons required are there in fission process. Yes. So if there is decrease in number of neutrons, then naturally the process becomes slow. Therefore, deuterium oxide is preferred than H2O as moderator. So why? Deuterium oxide slows down neutrons better? No. Deuterium oxide has high specific heat? No. Deuterium oxide is cheaper? No. The neutron absorbing ability of deuterium oxide is higher. Yes. Therefore, what it will do? It will absorb, yes, deuterium oxide will absorb more number of neutrons. Yes. Next, consider the following statements. Atomic hydrogen is obtained by passing hydrogen through an electric arc. Hydrogen gas will not reduce aluminum oxide. Finely divided palladium adsorbs large volume of hydrogen gas. Pure nascent hydrogen is best obtained by reacting Na with C2H5OH. Yes, okay. So which of the above statements is or are correct? Is it only first one or only second one, or first, second, third, or second, third, fourth? See, atomic hydrogen, we have seen the methods of obtaining atomic hydrogen. When electric arc is supplied through this H2O, we get atomic hydrogen H. I'm sorry, we don't write it like this. We write it as H. Yes, we represent it as H. Correct. And then we get OH. So atomic hydrogen is obtained by passing hydrogen through electric arc. So H2 when you pass it through electric arc. That is when you subject it for electrolysis, you get atomic hydrogens, H plus H, or I can write it as 2H. Hydrogen gas will not reduce heated aluminum oxide. Yes, it will not reduce heated aluminum oxide because aluminum oxide is a protective layer which becomes stable. And hydrogen being present below aluminum, it cannot reduce aluminum oxide. Finely divided palladium adsorbs large volume of hydrogen gas. See, for the process of adsorption, I can tell you one important thing. Since adsorption is a surface phenomena, it is a surface phenomenon. Okay. Since it is a surface phenomenon, as surface area increases, adsorption also increases. Adsorption also increases. So when you take palladium like this, the adsorption occurs here, correct? It occurs like this, adsorption onto the surface. But when you take this palladium in powdered form, on each molecule the adsorption occurs. See, on each molecule adsorption occurs. This molecule adsorption, this molecule adsorption, this molecule. So as you take it in finely divided form, the surface area increases. Therefore, large volume of hydrogen gas gets adsorbed. So this statement is also correct. Pure nascent hydrogen is best obtained by reacting with Na with C2H5OH. No, here we don't get pure nascent oxygen because salt is also present. So which is the correct option? It is option first one, second one, and third one. So option C is the correct option. Option C is the correct option. Yes. Next question. The low density of ice compared to water is due to hydrogen bonding interactions, dipole-dipole interactions, dipole-induced dipole interactions, induced dipole-induced dipole interactions. Now, the density of ice is less compared to that of water. Why it is less? Tell me. The reason is when you see the structure of ice, crystal structure of ice, crystalline lattice we say, of ice, if you see, of ice, see this ice due to formation of intermolecular hydrogen bonding, they will occupy hexagonal layers, large volume hexagonal layers, correct? So there are large volumes. The volume becomes more. Since volume becomes more, the density becomes less because density is inversely proportional to volume. So because of large volume hexagonal layers, what happens? The volume increases and therefore density decreases. Why it increases? Because of hydrogen bonding. So due to hydrogen bonding, H2O forms hexagonal cage-like structure in solid ice, and because of which the volume increases and therefore the density is reduced. Therefore, the low density of ice compared to water is due to hydrogen bonding interactions. What is formed when calcium carbide reacts with heavy water? Right, the reaction. Calcium carbide is CaC2. Yes, when it reacts with heavy water, D2O. So when calcium carbide reacts with heavy water, it forms, deuteroacetylene, C2D2. Yes, this is acetylene if it is normal water, deuteroacetylene, and CaOD twice, calcium deuteroxide. We have seen these reactions. So this is what? Deuteroacetylene, C2D2, and CaOD twice. So which is the correct option? It is option A. Along with that, CaOD twice, calcium deuteroxide is formed. Yes. Next question. Which of the following is formed on reaction of carbon monoxide gas with dihydrogen in presence of cobalt as catalyst? Carbon monoxide gas with dihydrogen is called what? It is called water gas. Let me show it here. Carbon monoxide gas, CO, we'll take a darker one. Yes, carbon monoxide plus H2 dihydrogen. This mixture is called what? It is called water gas. It is called water gas. or it is also called what? It is also called synthesis gas, or you can also abbreviate it as syngas. Why it is called as synthesis gas or syngas? Because it is used in the manufacture of various chemicals, especially when carbon monoxide is mixed with this mixture, that is water gas, when it is treated in presence of cobalt catalyst. Yes, sometimes they mention nickel also. Cobalt as catalyst. Yes, what we get is at around high temperature, 1270 Kelvin temperature, we get CH3OH. We get CH3OH in liquid form. This is called methyl alcohol, a common name, methyl alcohol you can call, or the IUPAC name is methanol. It is an organic compound. So the mixture water gas, it is used for synthesis of various chemicals. That one such chemical is methanol. Methanol, methane, and formic acid are not prepared. Methanol is prepared. Yes, therefore, it is used in the manufacture of methanol. Next question. Water possesses high dielectric constant. Therefore, so due to high dielectric constant, what happens? It can dissolve large number of compounds in it. Yes, it can dissolve large number of compounds. So water possesses high dielectric constant. Therefore, what will happen? It will always contain ions. Not necessary. Water contains ions. Polar solvent it is. It is a universal solvent. Yes, it is a universal solvent. It can dissolve large number of substances. Therefore, I can say, since water possesses high dielectric constant, I can say it acts as good solvent. It acts as good solvent. Therefore, I can quote it as a universal solvent. We can call it as universal solvent. Next question. The melting point of solid substance increases with increase in pressure. However, ice melts at a temperature lower than its usual melting point when pressure is increased. Why? See, ice occupies more volume than water, correct? And we know it why. Actually, solid, if it is there, it will occupy less volume. But here, in case of ice, due to intermolecular hydrogen bonding, the arrangement of the crystal is hexagonal layers which have large volume. Because of large volume, because ice occupies large volume than water, liquid water, increase in pressure favors what? Increase in pressure favors forward reaction. It favors forward reaction. Yes. So this principle is actually called Le Chatelier's principle, which you have studied in your equilibrium topic. It is called Le Chatelier's principle. Yes. So increase in pressure favors forward reaction to occur. Therefore, ice becomes less denser than water. Yes, because ice is less denser than water. Yes, ice is less denser than water. Is that right? Next, other options say pressure generates heat. No, it doesn't. Chemical bonds break under pressure. No, ice is not a true solid. No, ice is a true solid. It has got crystalline lattice. So ice is less denser than water. That is the reason. Okay. Next question. In context with the industrial preparation of hydrogen from water gas, CO and H2, which of the following is correct statement? Okay. CO and H2 are fractionally separated using differences in their densities. CO is removed by absorption in aqueous Cu2Cl2 solution. H2 is removed through occlusion with palladium. CO is oxidized to CO2 with steam in presence of catalyst, followed by absorption of CO2 in alkali. Okay. So when we talk about formation of CO and H2 at a large scale industrial process, see, on the industrial scale, hydrogen is prepared from water according to the following reaction. I'll just show you the reaction. CO plus H2 gives, see, first what is done is coke is taken plus water, we get CO plus H2. This mixture is called what? Water gas. It is called water gas, correct? This mixture of water gas, it is taken and treated with steam. It is treated with not water, it is treated with steam at around temperature 1273 Kelvin, correct? In presence of catalyst. Okay, that time what we get carbon dioxide plus H2. So here H2 is obtained under large scale. This is further treated with CO2. You want hydrogen to be taken out, right? So it is, if you want to remove out this hydrogen, you want to take this hydrogen, right? Industrial scale of manufacture of hydrogen it is. So to take out this hydrogen, what is done is, it is treated with alkali. It is treated with what? Alkali. Alkali is what? Base, that is NaOH. When you treat it with alkali, it will form Na2CO3 plus H2O. Na2CO3 plus H2O. Yes. So from the above reaction, it is clear that CO is first oxidized to CO2. Yes. Which is then absorbed in NaOH. Which is then absorbed in NaOH. So which is the correct option? Which is then absorbed, yes, in alkali, which is then absorbed in alkali. Yes, option D is the correct option. Calculate the normality of 10 volume of H2O2. Yes, okay. So let us calculate it out. So how do we calculate it? Normality of 10 volume, they have said, of H2O2. Correct? Okay. So 68, we know this. I'll not repeat the formula again. Into 10 upon 22.4. Molecular mass into 10 volume, they have said, upon 22.4 is the standard volume. This comes out to 17 into N. And we know that what is the value of N? Strength into normality. For normality, it comes out to 1.78. Yes, 1.78. So the correct option is 1.7 normality. 1.7 normality. Next question. The hydride ion H minus is stronger base than its hydroxide ion OH minus. Which of the following reactions which will occur if NaH is dissolved in water? Since hydride ion is a stronger base than hydroxide ion, what will happen is, yes, here we can expect, okay, so H minus, I'm sorry, it is H minus plus H2O gives OH minus plus H2. Why? Because H minus is stronger base. H minus is strong base. It will abstract H plus ion. Therefore, it will abstract, or you can say abstract H plus ion to form H2. So H minus will take H plus ion from water to form H2 gas. OH minus comes out. So which is the correct option? It is option B. It is option B. Is that right? It is option B. Next question. Okay. Match the list 1 with list and 2 and select the correct answer using the codes given below in this list. Okay. So first option, they have given this side heavy water, temporary hard water, soft water, permanent hard water. Then here they have given what all the ions are present. So we know that. So let me do it like this. Yes, we will take it here. Okay, heavy water is what? It is deuterium oxide. Correct. Temporary hardness of the water. See, hardness of the water is due to bicarbonates. It is due to HCO3 minus. These are bicarbonates. Sulfates, SO4 minus 2. And chlorides, Cl minus of calcium and magnesium. In that, we have temporary hard water and we have permanent hard water. Temporary hardness is due to bicarbonates, whereas permanent hardness is due to chlorides and sulfates of calcium and magnesium, right? So with this understanding, temporary hard water is due to what? It is due to bicarbonates of calcium and magnesium. Then what is soft water? Soft water that doesn't contain any foreign ions in water, right? Permanent hard water is due to sulfates and chlorides of calcium and magnesium. So with this understanding, which is the correct option? A, 4. Sorry, A is 3. So here A is 3. Okay, option A has. B is what? B is 1. No, here it is not correct. So A is 3, B is 1. C is what? C is 2. And D is what? D is 4. So this is the correct option. Yes. So this is the correct option. Option D is the correct option. Yes. So we can say heavy water is deuterium oxide. Temporary hard water contains bicarbonates of magnesium and calcium in water. And soft water doesn't have any foreign ions. Permanent hard water contains sulfates and chlorides of magnesium and calcium in water. Yes. Next question. When a substance A reacts with water, it produces the combustible gas B. And a solution of substance C in water. When another substance D reacts with this solution of C, it also produces the same gas B on warming, but D can produce gas B on reaction with dilute sulfuric acid at room temperature. Okay. A imparts a deep golden yellow color to smokeless flame of Bunsen burner. A, B, C, and D respectively are. See, such a nice question. It reacts with water, produces combustible gas. So combustible gas means it is hydrogen. So it should produce hydrogen. And a solution of substance C in water. And a solution of substance C. So some substance C is produced in water. So I can take this reaction like this. So we will take it here. Okay. So they have said what? They have said a substance when reacts with water, a substance A reacts with water and produces a substance combustible gas. So combustible gas should be hydrogen only. So they have called it as, so let me write it B here. Let us write it B here. And a solution of substance C in water. So this is solution and this is gas. Okay. Then when another substance D reacts with this solution of C. So this solution of C is taken. So this solution which is produced here, it also produces the same gas B. Okay, it is also producing the same gas. That means according to our assumption, since it is combustible gas means it is hydrogen only. So it is producing same gas B on warming. Okay, but what they have said, D can produce gas B. So D can produce gas B on reduction with dilute sulfuric acid, H2SO4 dilute, it can produce gas B. Yes, again, what is produced, we don't hear. A imparts a deep yellow color to the smokeless flame. A is giving us deep yellow color, dark yellow color, intense yellow color to the Bunsen flame is given by sodium metal. Okay, it is given by sodium metal. Fine. Therefore, A, B, C, D respectively are. So let us take it. Yes. So let us see what we can say. So since it is according to us, so A is what? Sodium. So it reacts with water to form what? To form a solution, NaOH, plus it gives hydrogen gas, combustible gas. Correct. Then what they have said further? D reacts with a solution, same solution, that is it reacts with NaOH. There is some substance D, it reacts with NaOH on warming. Yes, and forms same gas. So on warming, which metals react? The metals which react are, it is zinc, lead. So let me say zinc, because again D is reacting with H2SO4, they are saying. Therefore, D is what? It is zinc only. So here it produces what? Na2ZnO2, sodium zincate, plus it is liberating hydrogen gas only. And with dilute sulfuric acid, it is producing what? It produces with dilute H2SO4, it produces ZnSO4 plus H2 gas. ZnSO4 plus H2 gas. So this is the reaction. So A is producing combustible gas hydrogen and giving sodium hydroxide solution. D is nothing but our zinc, which reacts with sodium hydroxide on warming to form sodium aluminum zincate, and hydrogen gas is liberated. Same gas is liberated. D also reacts with H2SO4 dilute and liberates hydrogen gas. So which is our correct option? Sodium. A, B, C, D they have said. So A is sodium, B is what? B is hydrogen gas, C is sodium hydroxide, and D is zinc, because with aluminum and all it is not possible. Okay, next. At its melting point, ice is lighter than water. Why? See, when we speak about ice, yes, if you see the structure of ice, each molecule of H2O, it is surrounded by 3 molecules of H2O in hexagonal honeycomb manner. Yes, each molecule of water, it will be surrounded by 3 molecules of water molecules in hexagonal cage-like structure. On the other, in water, each molecule is surrounded by 4 neighboring molecules. Why? Because of intermolecular hydrogen bonding. And that results in the open cage-like structure. As a result, there are a number of holes, or you can say open spaces. In such a structure, lesser number of molecules are packed per ml, yes or no? Lesser number. So when ice melts, a large number of hydrogen bonds are broken. The molecules therefore move into the holes or open spaces, or you can say they come closer to each other than when they are in solid state. This results in what? This results in sharp increase in the density. Therefore, we can say ice has lower density than water. So which is the correct option? H2O molecules are closely packed in solid state? No, they are more freely packed actually. Ice crystals have hollow hexagonal arrangement of water molecules. Yes, that is the correct option. On melting ice, the H2O molecules shrink. No, they do not shrink. Ice forms mostly heavy water on first melting. No, it is because of option B. H2O2 is commonly prepared in laboratory by the reaction of. It is by barium peroxide with H2O. We can look into the reaction. Okay. So here we have the reaction. Barium peroxide, BaO2 is barium peroxide plus H2O plus CO2 gives what? It gives BaCO3 plus H2O2. And what is this process called? This process is called Merck process. It is called Merck process, correct? It is called Merck process. Okay. Next question. Which of the following is formed by the action of water on sodium peroxide? Sodium peroxide. Take the reaction. Action of water on sodium peroxide. Na2O2 plus H2O. Yes, water. Gives what? It gives NaOH, 2NaOH plus H2O2. This H2O2 dissociates to give H2O plus O2. Yes. So which is the correct option? The correct option is oxygen gas is produced. Oxygen gas is produced. Next question. The reaction H2O2 to H2O plus O2 shows that H2O2 is. See, H2O2 is becoming H2O plus O2. So what it shows? H2O2 is what? It is decomposed to H2O and O2. So it is decomposed. It is decomposed. True peroxide is. See, true peroxide is what? It should contain this peroxy linkage, O linkage. If this linkage is present, then it is true peroxide. If you look at barium peroxide, and it should have this O2 minus 2 ion, correct? O2 minus 2. This is peroxide ion. So they give hydrogen peroxide with dilute H2SO4. Only they give hydrogen peroxide with dilute H2SO4, and it is what? It is barium peroxide. Next question. The component present in greater proportion of water is. Water gas is. The component present in greater proportion. So I will tell you 40 to 50% in water gas is carbon monoxide. 44 to 50% is H2. 54%. Okay. 40 to 50 is CO. 44 to 54% is H2. 3 to 7% is CO2. and 4 to 5% is N2. 4 to 5% is N2. So which is the correct option? So it is H2, water gas. Okay. Next, which physical property of dihydrogen is wrong? Odorless, tasteless, colorless. It is highly inflammable, not non-flammable, non-inflammable. It is highly inflammable. So this is wrong statement. In which of the following reactions H2O2 acts as a reducing agent? So where the oxidation state decreases, there it acts as reducing agent. Option A, PbO2 plus H2O2 gives PbO. So here oxidation state of Pb is changing from +4 to +2. So this is what? This is reducing agent. Look at the other reaction. There is no change here. Here it is oxidizing. This is also oxidizing. Yes. Therefore, option A itself is the correct option. So where oxidation state decreases, that is the correct reduction nature. Commercial 10 volume of H2O2 is a solution with a strength of approximately 10. Did we miss any question? Okay, no. So commercial 10 volume of H2O2. So strength they have asked. So let us see. Strength of 10 volume of H2O2 is 68 into 10 divided by 22,400 into 100. This comes out to what? Solve it out, it comes out to 3.035%. 3.035%. So which is the correct option? It is option B, 3%. Which of the following is not true? Deuterium oxide freezes at low temperature than H2O. Reaction between H2 and Cl2 is much faster than D2 and Cl2. Then ordinary water gets electrolyzed more rapidly than D2O. Bond dissociation energy of D2 is greater than H2O. So see, if you just see, deuterium oxide actually has high freezing point. Yes, freezing point of deuterium oxide, it is 3.8 degrees Celsius. When you compare it with water, we know water is 0 degrees Celsius, right? So it freezes at low temperature than deuterium oxide is not true, because it freezes at high temperature than normal water. Yes. Next, when zeolite hydrated sodium aluminum silicate is treated with hard water, the sodium ions are exchanged with. Look at the reaction actually. So here zeolite, they have said sodium. So zeolite it is. Okay. So I'll write sodium zeolite plus CaCl2. It gives hard water, right? Calcium zeolite, calcium zeolite. So which ions are exchanged? Calcium zeolite plus NaCl. So which ions get exchanged according to our option? H plus ions? No. Ca plus 2 ions, or SO4 minus 2 ions, or OH minus? It is Ca plus 2 ions. Yes. Which statement is wrong? Ordinary water is an equilibrium with mixture of ortho and para-hydrogen. In ortho-hydrogen, spin of two nuclei are in same direction. Ortho and para forms do not resemble in their chemical properties. In para-hydrogen, spin of two nuclei is in opposite direction. So which statement is wrong? Ordinary hydrogen is an equilibrium mixture of ortho and para-hydrogen. Yes. In ortho-hydrogen means what? The two nuclei spins are in same direction. Para-hydrogen means they are in opposite direction. So B and D are correct. Ortho and para do not resemble in their chemical properties. Yes, they do resemble in their chemical properties. They are finally hydrogen atoms. Only the spin of the nuclei doesn't make any difference in chemical properties, right? So option B is the wrong statement. They have same chemical properties. Next, water contracts on heating. Water contracts on heating when? So what happens when on heating? See, when water is heated, what happens? From, correct option is actually option B. From 0 degrees to 4 degrees Celsius, what happens when you heat? Its density increases. Its density increases. Okay. So since its density increases, what happens to the volume? Density is inversely proportional to volume. Therefore, volume decreases. So water contracts on heating from 0 degrees Celsius to 4 degrees. Water is more polar than H2S, more or less identical in polarity with H2S, less polar than H2S, none of these. Polarity of bond depends on what? Depends on difference in electronegativity of the two concerned atoms. H2O is more polar than H2S. It is more polar than H2S. The reason is oxygen OH bond in water, it is more electronegative difference than in SH bond. Therefore, the correct option is water is more polar than H2S. Okay. Lithium aluminum hydride is used as oxidizing agent, reducing agent, mordant, and water softener. See, lithium aluminum hydride, it is a most useful organic reducing agent. It is prepared. See, lithium hydride treated with aluminum chloride, you get AlH3n times. You take excess of again lithium hydride, you get lithium aluminum hydride. This is how lithium aluminum hydride is prepared, H4. This is a strong reducing agent. Strong reducing agent. Yes, so it reduces functional groups. But remember, lithium aluminum hydride does not attack double bonds. It does not attack double bonds. So it is a reducing agent. Hydrogen is not obtained when zinc reacts with. Only elements having reduction potential less than 0.41 volts liberate hydrogen in cold water. Yes, but hydrogen, it does not react with zinc with cold water. It is hydrogen gas is not obtained when zinc reacts with cold water because its reduction potential is high than 0.41. An organic compound gives off O2 when heated, turns acidic solution of Ki violet, reduces acidified KMnO4 solution, the compound is. Okay. So let us see the reaction. So see, H2O2 on heating, we know it gives H2O plus O2, correct? Ki when treated with H2O2 gives what? KOH plus I2. So this violet coloration is displaced. KMnO4 plus H2SO4, acidified KMnO4 plus H2O2 gives K2SO4 plus MnSO4 plus H2O plus SO2. So with all these three reactions, which is the correct option? So an organic compound gives off O2 when heated. So it is organic compound is H2O2. On heating, it gives O2 gas. Turns acidic solution of Ki violet. So Ki turns violet because of formation of I2 gas. Violet. Reduces acidified KMnO4. So the organic compound is H2O2. Which of the species that does not contain peroxide ion? H2O2 contains strontium peroxide, barium peroxide. This is lead oxide, not peroxide. Yes, it does not contain OO bond, peroxy linkage, nor it contains O2 minus 2 ion. It is O2 minus, above, not below. Yes. Next. Metal hydrides are ionic, covalent, or molecular in nature. Among lithium hydride, sodium hydride, potassium hydride, rubidium hydride, cesium hydride, the correct order is. See, as you move down the group, metallic hydride nature, they are ionic, molecular, covalent. It decreases. It increases. So which is most? Lithium hydride is more ionic. Then comes sodium hydride. Then comes potassium, rubidium, and cesium. So option B is the correct option. Which of the following is incorrect statement? S block elements except beryllium and magnesium form ionic compounds. Yes, it is correct. Beryllium hydride, magnesium hydride, copper hydride, zinc hydride, calcium hydride, mercuric hydride are intermediate hydrides. Yes, that is also correct. Here ionic and here covalent. P block elements form covalent hydrides. Yes, it forms covalent hydrides. D and F block elements form ionic hydrides. See, D and F block elements, they form metallic hydrides. They form what? Metallic hydrides. Yes, S block elements except beryllium and magnesium, they form ionic hydrides. These hydrides are intermediate hydrides, but D and F block, they do not form ionic. They form what? They form metallic hydrides. So that is the incorrect statement. Next question. The decomposition of H2O2 is accelerated by decomposition of H2O2. It is accelerated by finely divided metals. And those metals are, you can say, gold, silver, platinum, cobalt, and iron. So it is platinum powder. Yes. Molarity of 100 ml solution containing 5.1 grams of hydrogen peroxide. Molarity. So 5.1 grams into 1000 divided by, they have said 34 into 100. Yes. So what do we get? The answer comes out to 1.5. Solve it out. You will get 1.5 molarity. Permanent hardness of water can be removed by Calgon. Yes, this is Calgon. This is what? This is zeolite. This is an example of what? Where there occurs exchange of ions. So ion exchange method it is. Calgon's method. Correct? Last question. The oxidation state of most electronegative element in the product of reaction BaO2 with dilute H2SO4. Barium peroxide plus dilute H2SO4 gives barium sulfate BaSO4 plus H2O2. So oxygen here, if you see, has common, most electronegative element is oxygen here. So oxygen has a common oxidation state of -2, and in peroxides it is how much? It is -1. It is -1. So from -2, sorry, here it is peroxide. In -2 it is becoming -1. So common is what? -1 and -2. -1 and -2. So that is the correct option. So common oxidation state of oxygen is -2. But in case of peroxides, it becomes +2. So this is all about hydrogen. Hope you have followed all the concepts and you have got cleared with all the questions. Yes. So with this, I finish the multiple choice questions on hydrogen topic. In the next class, we'll go with the next topic. Thank you.